This is continuation of section 4.2, graphing quadratic functions. First of all, we have the vertex form, y equals a times x minus h squared plus k. The vertex is found at the point hk. Now notice in here in the equation this says minus h inside the parentheses. When you bring it down here, it's going to be positive h. So it's always going to be opposite of what's inside the parentheses. And this is going to be the same sign for the y value of the vertex. And then the axis of symmetry has to go through the x value of the vertex, so that's going to be at x equals h. It'll be the vertical line, x equals h. Now if I wanted to graph one of these in vertex form, there are a couple ways you could do this. We figured out in the last section how to put this into standard form, which you can certainly do. You could multiply this out, put it in standard form, and then graph it just like we did the standard form graphs. The cool thing about this equation, though, is that the vertex is right here ready for us to graph. So I'm going to start with that. I'm going to find the vertex, and the vertex is going to be the opposite of what's inside the parentheses, so positive 4, and the same sign as what's hanging out here, which is negative 3. Okay? So our vertex is going to be at the point 1, 2, 3, 4, negative 3. So I can go ahead and graph that point. Now the other nice thing about this, I know that the axis of symmetry is going to be the x value of the vertex. So the axis of symmetry is going to be at x equals 4. So if I want to go ahead and graph that, and remember we use a dashed line for the axis of symmetry, there is the axis of symmetry line at x equals 4. Now what I need to do is I can just pick a point for x. Okay? If I have my x at 4 here, don't go too far away from the axis of symmetry. If we go too far away, like if I decide to use x equals negative 9, it's going to be way off the graph. So try to stay very close to this 4. I usually use, my rule of thumb is 2 away. So I could either use positive 2 or I could use positive 6. And again, it doesn't matter. I could use any x that I want to. I just like to stay close just to make sure that the graph fits on the piece of graph paper that we have. I'm going to go ahead and plug in x equals 2. Okay? So if x equals 2, if I go back to the equation, y equals 1/2 times 2 minus 4 squared minus 3. Inside parentheses first, so I've got 1/2 times negative 2 squared minus 3, which is going to be 1/2 of 4 minus 3, which is going to be 2 minus 3. So when x is 2, y is negative 1. Okay? So I just found another point on the graph at 2, negative 1. So I'm going to go ahead and plot that. 2, negative 1 is here. And then remember, the cool thing about the axis of symmetry is that I have to have a mirror image on this side. So there's another point, and that gives me my parabola. And just a quick check, this graph should be going up because this number right here is positive. If that number would have been negative, the graph should have been going down. But that's just a quick check to make sure that at least the parabola is going the right direction, and that one is. Now let's talk about intercept form. Intercept form is pretty cool because it tells us what the x-intercepts are right in the equation. They are going to be at the points P0 and Q0. Notice again, inside the parentheses, I'm thinking opposite. So it's the opposite of what's in here, so it's at positive P0, and opposite of what's in here, so positive Q0. And then the axis of symmetry is a little bit different now because it's going to be halfway between those 2 points. Since they're both falling on the x-axis, they have to be mirror images of each other. So it's going to be halfway between those 2 points. And again, there's two ways to graph these. You could, because we already learned how to put an equation like this into standard form, you could multiply it all out, put it in standard form, and use the standard form of graphing that we learned in the first video. Or we can go ahead and use these x-intercepts that are right in the equation. Okay, so I'm going to go ahead and write those down. My x-intercepts are going to be at -3, 0. Okay, remember opposite of what's in the parentheses, so it'd be -3, 0. And I'll also have an x-intercept at +1, 0. Again, opposite, so +1, 0. So I'm going to go ahead and graph those. Here's -3, 0, and here's 1, 0. Now I know that the axis of symmetry is halfway between -3 and 1. So you can do this a couple ways. You can go ahead and count in 1, 2, then I count in 2 this way, so it's going to meet at -1. Or you could find the average of these. -3 plus 1 is -2. Divide by 2, you'd have -1. So I know the axis of symmetry has to be at -1. And that's going to be the line x equals -1. So I'm going to go ahead and graph that. Remember, this is still going to be dashed. Okay, because it's not actually part of the parabola. It's just what shows us where the mirror image of the parabola is going to be. So now that I have the axis of symmetry at x equals -1, I also know that the vertex has to fall where the x is -1. Okay, the vertex always falls on the line of symmetry. So if x is -1, all I need to do is just go in and plug -1 into the equation. So I'm going to do that quick. So it'll be y equals -1/3 times, and I'm going to go ahead and do this, -1 plus 3 would be 2. Okay, I'm plugging in -1. And then -1 minus 1 would be -2. Okay, and if I multiply this out, since multiplication is commutative, I can multiply these first. 2 times -2 is -4. -4 times -1/3, I'm going to go ahead and write this out quick. -4 times -1/3 is going to be +4/3. So that is the y of my vertex. So now on the axis of symmetry at -1, I'm going to go up to 4/3, which is about 1 1/3, so that's going to be right about in here. And that's going to be my vertex, so I can go ahead and sketch the parabola. And a quick check to at least make sure that our graph is going the right direction. This number out in front is a negative. That tells me that this graph should be going downward, which it is. So my graph is finished. And that's going to conclude section 4.2.